Hi students, I'm Naveen Bansal and welcome back to the Math Navigator. Today we are diving deep into the topic vectors. If you have been struggling with this topic or finding yourself stuck on the methods, remember our golden rule here. Stop guessing, start navigating. Before we jump to the topic, a quick heads up. If you need personalized help to crush your upcoming exam, I offer one-to-one session. My contact number is right there in the description below. Feel free to reach out and let's get your grades on the right track. All right, grab your calculators and your formula booklet. Let's navigate the topic. So today we are going to do vectors, which is very important topic, right? So when we are talking about vectors, we know that there are two types of physical quantities, scalars and vectors. Scalars, they have only magnitude associated with only magnitude. And vectors, they have magnitude as well as direction, right? So let's say this is your house and this is your school, right? Let's say it is 10 kilometers. So if I'm saying drive 10 kilometers, this 10 kilometers represents magnitude. But let's say if I'm saying drive 10 kilometers towards school. So 10 kilometer is your magnitude and towards school represents, got it? Right. So now when we want to represent the vector, how the vector is represented? Yes. So we represent it as vector A. This is read as vector A. Now, as I've told you, we have to, in order to define the vector completely, we need to have the magnitude as well as direction. So it is represented as vector A times direction. So this vector A represents the magnitude and this things represents direction. This is also read as A cap. This is unit vector. Got it? Unit vector means it is like a vector only but has magnitude of. So okay, let's first understand one thing. Let's say this is a point here. I can represent this point as 3, 2. That means if I'll say it, 3 units along x-axis, 2 units along y-axis, right? So I can write it like 3, 2. Another, this you have been doing since your the lower classes. Now we can write it like as 3i cap plus 2j cap or p2. This is called column vector. And this I cap is direction along x-axis. J cap is direction along y-axis. And your k cap is direction along z-axis. So how do we represent the vectors graphically? This is the, like if I'm saying my vector is 1, 2, 3. This means 1 unit along x-axis, 2 units along y-axis, and 3 units along z-axis. Now when we are saying This is called component form. That means I've resolved the vector into three components, x, y, and z. But how do I represent it graphically? A vector is represented by line with an arrowhead, right? So when I'm saying line with an arrowhead, this length of line represents magnitude. And this arrowhead represents direction of vector. Here, very. Now I'm saying this is my vector A, right? Or let's call this as vector A, right? I can write it as 2A cap. This means my direction is along A and my magnitude is 2. This is arbitrary direction. Arbitrary means we don't know what is this direction, but we know that is certain direction. Got it? So if I multiply this with 2, it will become 4A cap. That means the new vector will be twice the length, but same in direction. Is this clear now? Very good. So let's say if I'm saying this is my vector A, let me multiply this with negative of 1. So this will become negative 1A. This means vector is same in magnitude, but opposite in direction. So this is called negative of a vector, right? So I hope you are clear with the concept of vectors. Now, since we have like the operation, mathematical operations, addition, subtraction, multiplication, division, same way we have some operations in vectors also, which is addition, subtraction, dot product, and cross product, right? So vector can be given to us in two forms, the graphical form as well as the component form. So if I'm saying vector A is equal to 1, 2, 3, and vector B is equal to 4, 5, 6. So in this video, we are going to do only the basics of like the addition, subtraction, dot product, and cross product. How do we find them? In the next video, we will talk about the use of them when we further move to vector applications, right? So first we need to understand how do we add two vectors. So if I have to add two vectors, vector A plus vector B, this will be 1, 2, 3 plus of 4, 5, 6, which will give me 1 plus 4, 5, 5 plus 2, 7, 6 plus 3, 9. So this is my vector A plus vector B. But how will I do when I have got vector A here and vector B here? So what I need to do is I need to write this vector like this and take this vector like this. So this vector will give me vector A plus vector B. So this is called triangle law of vector addition. Which is if two vectors are represented by two sides of a triangle taken in the same order, then the third side represents the resultant if taken in the opposite order. Got it? Yes. Now, so this is how do we add the vectors. Next, we'll do vector A negative vector B. So if I'm doing vector A negative vector B, so these are my vectors. Let's tap them from here, right? And put it here. So now I have vector A minus vector B. So vector A minus vector B will be 1, 2, 3, minus 4, 5, 6, which is negative 3, negative 3, again negative 3. So this is my vector A minus vector B. So this is how you'll do vector A minus vector B. But let's see if I have to do vector B. So how will you do vector A minus vector B? So vector A minus vector B can be written as vector A plus of negative vector B. That means addition of negative of a vector B to vector A. So this means vector A, this is my vector B. So negative of a vector will be taken in the opposite direction like this. So this thing will give me the resultant. So this is vector A negative vector B. This is the answer, right? Got it? Very good. Please clap for yourself because you have understood very quickly. Right. Perfect. Now we'll talk about the dot product. This is written as like this. Dot product. So vector A dot vector B is written as AB cos theta. This you have to just understand like this here. A is equal to magnitude of vector A and B is equal to magnitude of vector B. So when I'm saying like what is this theta then? This is, if this is vector A and this is vector B, always remember here you have to match tail with tail. This is the angle between them. You cannot do this and say, oh, this is the angle between the two. This is wrong. This is the correct way of doing it, right? So in dot product, you have to match tail with tail. Another way, so if I have a vector 1, 2, 3, which is vector A, and vector B is 4, 5, 6. So now what happens? If I want to do vector A dot vector B, this is equal to 1, 2, 3 dot 4, 5, 6. This will be 4, 10, 18. Sorry, give me a quick moment, please. This will be written as 1 times 4 plus 2 times 5 plus 3 times 6, which is 4 plus 10 plus 18. This will be 22 plus 10, 32. So 32 is my answer. Right, perfect. You have understood it very quickly. Now, let's talk about we'll do the angle between the two vectors later when we'll do lines and planes, right? So this is how you'll find the vector A dot vector B. Now let's talk about the cross. This is basically used to find the angle between the lines and to decide whether the lines are parallel or perpendicular. This will decide later, right? The next thing is vector A cross vector B. As we have seen in vector C, in order to I like describe the vector completely, we need two things: magnitude as well as as well as direction. But dot product is scalar. That means it doesn't have any direction. It only has a magnitude. But cross product of two vectors is a vector quantity. This will be more used when we'll be doing planes. So this is decided as AB sine theta. But here is one twist. Here you have to put direction also. So this n cap represents direction, which is arbitrary direction. And we have to find the complete. So let's say if I ask you again, this is my 1, 2, and 3. And this is my 4, 5, and 6, right? So if I'm doing vector A cross B, please listen to this very carefully. You have to make something like this and put I cap, J cap, and K. This is the way of solving it, right? So just remember it. We have to solve it this way. So vector 1, 2, and 3. This is the first vector, vector A. And second vector B will be 4, 5, and 6. So if I want to find I cap, I'll write I cap and then I'll hide this part and then I'll cross multiply. So first I have to do 2 times 6 and then put a negative sign here, then 3 times 5. This is like discriminant, which we do in matrices, but matrices is not in the syllabus of AHL or even ASL, right? So this we have to do. When I want to find J, I have to put a minus sign and write like this, J cap. And then I have to hide this part. So 1 times 6 minus 3 times 4. And if I want to find K, now remember this time we have to put plus K cap. So K cap will be this. Now this is 1 times 5 minus 2 times 4. So my answer is I cap 12 minus 15, which is negative 3. Negative J cap, then 6 minus 12 is negative of 6 plus K cap, which is 5 minus 8, that is again negative of 3. So negative 3 I cap plus 6 J cap minus 3 K cap. So this is my answer. So this is my vector product. But we have to remember one very important concept. Let's say these are the two vectors, vectors A, vector B. The cross product of these two vectors is always perpendicular to both. This is very useful concept when we'll be doing planes. So let's say if I have two three-dimensional lines, 1, 2. So this is line L1, this is line L2. If I'll do the cross product of these, then this vector is the resultant. And this is perpendicular to both line L1 and L2. This will become more clear when we will do vector applications. So today what we have done the basics of the vectors, and then we have done the addition, subtraction, dot product, and cross product. I hope this is clear to all. In the next video, we will discuss the vector applications and do some questions on it, right? So I hope this is clear, right? So we'll meet next time very soon. Okay, thank you, students. And please subscribe to my channel.